Hi, it's Dave. Welcome. Today, I'm joined by Soroush Nazarpour. He is the CEO and founder of NanoXplore. They're based in Montreal, Canada, and I'm super excited. Welcome, Soroush.
Hi Dave, how are you?
Doing great. Thank you. Thank you for being generous, taking your time out to share with me and my
Great
audience
to
here.
be here.
Yeah, so today in this interview, I want to dive into graphene. I know you guys are a graphene company based in Canada, one of the world's largest producers in terms of capacity. And I want to dive into kind of what is graphene, how you guys make graphene, the future applications of graphene, and kind of your history and everything. But I know there's a lot to cover, but let's first get started and dive into like what is graphene. Can you kind of give a high level view of graphene, the history of graphene, and maybe its potential uses?
Right, so graphene is a material that's been discovered at 2004, right? This material is the first two-dimensional material ever known to human. It got the Nobel Prize at 2010 by the two profs from University of Manchester that they discovered it for the first time. And what it is if you think of graphite, natural flake graphite, the graphite powder or the type of graphite that you have in the pencil, um, it's consisted of a bunch of layers of graphene sitting on top of each other, right? So all these layers, which are two-dimensional, come on top of each other and build a three-dimensional material, which is called graphite. Now, what we do, or let's say what graphene companies are doing, are exfoliation of this graphite layer by layer to end up with this graphene, which is two-dimensional. Now, why anyone care about graphene and why it got the Nobel Prize is because, well, being the first two-dimensional material, it brings a lot of cool properties. Like it is the most electrically conductive material in the world, and it's more conductive than copper. It's also very strong, and its strength is great. It's like a carbon fiber on a steroid. At the same time, it's flexible and bendable. It's transparent, but at the same time, has this capability of separating, let's say, water from the other type of chemicals in it. And all this magnitude of properties happen in one single material, which is very unique. It's called multifunctionality. Normal materials out there like copper, it's used for conductivity. Steel is good for strength, but one material bringing everything together, it's unique. And this multifunctionality is the reason it got the Nobel Prize. So you can use graphene for a plethora of different applications. Like you can actually add it to the plastics and make them stronger or make them conductive. You can actually add it to the batteries, increase the capacity of the battery, increase the charging speed of the batteries. You can actually add it to, let's say, coating and make it anti-corrosion. You can add it to, you name it. There's a lot of different applications that graphene can do, and all in all, it's the reason that this is a very unique. It's a type of futuristic material.
Hmm. I'm curious, like when you say the first 2D kind of material out there, um, what do you mean by that? I mean, is it just so thin that it
Yeah,
basically isn't a 3D in terms of volume? It's just so thin. It's like one flat layer. Is that the concept?
exactly. It's like a piece of paper, right? So
Hmm.
the lateral dimensions are nanometer or even larger in micrometer, but in terms of thickness, it's so thin that it's not really a dimension. That's why it's two-dimensional.
Got it. How many atoms thick is it usually?
So in terms of thickness, it's actually one.
Okay.
So one atomic layer, it's called single layer graphene. And then if you have two of these layers sitting on top of each other, called two layers graphene. And if it's 10, it's called graphene nanoplatelets. And it's all about the number of the layers of graphene that the producer or manufacturer produces.
Okay. And what kind of graphene do you guys produce specifically?
So we are capable of producing, as single layer all the way to 10 layers, but our core business is between 6 to 10 atomic layers. That's where we found the best combination of cost, performance, and also stability for the end users, because this stability is something we can talk more about. But you got to have consistency in your production. At the same time, you got to be able to use it. If it's too thin, it's too fluffy, it's too hard to use it. If it's too thick, it doesn't have the performance. So there's a combination of properties that you have to consider when you produce graphene.
Mm-hmm. I'm curious with back to this kind of 2D idea of the first 2D material. Can you explain a bit more on its significance? Like, why is a 2D material, significant? Why would it be, I guess, different than, let's say, other materials?
So it all comes back to a concept called surface area. So as much higher surface you have, as more of a properties you have, right? So some of the properties comes from like conductivity. If you have something very fluffy, you have a lot of surfaces, you have a lot of path for electrons to pass from one side to other side. So high surface area means higher performance. And at the same time, there is a concept in quantum mechanics, when you start to go smaller in terms of size, properties are different from larger particles. For instance, even a simple thing like a melting point of something like gold, a melting point of that goes from, let's say, 800 degrees down to 400 degrees when you go from gold to nanogold, right? So when you reduce the thickness, properties and the trade-offs changes. And typical trade-offs in the world is if something is stronger is heavier, right? Like you have steel, it's very strong, but it's also heavy. Now, if you turn around and look into the concept of density, graphene has very low density, but it's still very strong. So this type of typical trade-offs that you have in the world is not valid in nano world. Now add that to a super high surface area material, which magnifies all the properties that you have. So that's why you get crazy performance.
I see. Got it. Yeah, I want to go, let's go into some of these potential uses. I'm super curious, but first I want to go into kind of NanoXplore, your company. So can you kind of share a bit about kind of your state of production? Like, I know you guys are perhaps the largest graphene producer, at least in terms of capacity in the world. Can you explain what that capacity is? And also maybe kind of what your unique approach is in terms of making graphene?
Right. So, well, the worldwide production capacity of graphene is shy of 9,000 tons, and we have a facility that does 4,000 tons. So from 9,000 tons to 4,000 tons, we have about 45% of global capacity in the production of graphene. Okay. And what we do is it's a technology that we developed in house like 7-8 years ago, and we start from natural flake graphite and we exfoliate that graphite to graphene in a single step. Our process is a water-based process. It's unique in terms of simplicity of the process. At the same time, it's a very chemical reaction that happens. But what we do is we technically get graphite, and in one step, first of all, we increase the spacing between the layers. So like a popcorn, we just pop the graphite, and then afterwards we apply shear force to that and tip them off, and layer by layer we exfoliate. So that's a simplistic version of our technology. And we took this technology and scaled it up many times in the lab till we got to this facility that by itself it's not large for chemical world, but it's the largest in the world by far. And it's a batch type process. It's a modular plant. Batch type process gives you the chance that you time the production with your cells, and it helps you to minimize your inventory, minimize your the amount of inventory that you carry in a single point of time. At the same time, it's a modular facility. So for us to build another 4,000 ton facility, it's a 6-month time, and we put another 4,000, like a copy paste existing line, and we do another one. At the same time, it's way lower cost than anything in the world now. That the problem of the graphene and the commercialization of that was the cost. It has been just super expensive. And we tackled that, and we reduced our cost of production significantly versus anyone in the world, and we brought the selling price down to a level that normal chemicals are being sold. That's for us was a tipping point to start to capture market.
Okay. Out of the 4,000 ton capacity that your current plant has, what is it running at in terms of production? Is it at the full production or is it near there?
So it's not yet at the full production, but we're getting to the full production in the probably next 18 months.
Okay.
So where we are with that is, we time our production with our sales, and for a new product like graphene, you go through a long validation cycle with the customers, and so technically the big difficulty in that is customers to use it, they need to know you actually can produce it, right? So we actually got the plant up and running. That gives us enough validation that actually we can produce it at a cost that makes sense for the users. So it helps us accelerate the process of commercialization. Right now, we're capturing a bunch of markets, like in transportation, we're doing pretty good. In consumer electronics, in consumer packaging, we're doing good. In batteries, we're doing very good. So these are the type of markets that we're doing good, but there are a lot of different customers, and they're growing. So that's why we see a very decent ramp up going forward.
Okay, got it. So what percent of capacity would you guys say you're running at right now with your plant?
Well, we haven't disclosed this information because we didn't provide any sort of guidance to the market. But I can tell you we are definitely doing better than a shift of production.
Okay, got it. Sounds good. And then in terms of I noticed your revenues for 2020 and 2019, it seemed pretty similar. I think it was between 60 and 80 million. Was there a reason? Can you explain a bit more? Are you waiting for kind of these purchase orders to come in before you kind of see a additional kind of growth in revenue? Or what was the past 2 years, and what was the context of background of kind of more of sales that were similar for 2 years?
Well, the plant is up and running for about 2 quarters. So we didn't even have the production capacity in terms of growing sales. I mean, you just can't sell if you don't produce. So we have a small, let's say, loading of graphene in general into the parts. So in our composite business unit, we are selling parts to the truck market, the bus market, but the use concentration of graphene is about 1-2%. So for those applications, we had a pilot facility before this plant that was pretty sufficient. And even though you don't really see the sales number growing, but there is content of graphene going to those products and improving the bottom line, right? So we let's say 2 years ago that we acquired a company called Sigma Industries, which was involved in the composites. We acquired the company at close to 4% of EBITDA, and today at the pre-pandemic sales levels, we are at close to 9% of EBITDA. And that growth that we brought in, of course, there is a portion of it comes from the operation improvement. There's also a portion coming from the added values that comes from graphene. And most of the time, you don't want to increase the selling price to increase the revenue. You just want to improve the product and reduce your costs and increase your bottom line and profit margins.
Okay, got it. So would most of your sales then, I guess prior to the past quarters, would that be more in these other lines or through your acquisitions, or where is the revenue coming from?
Yeah, most of the revenue is coming from our composite business, which technically you're selling composite parts, which is we sell parts to truck manufacturers, to the OEMs, to the bus manufacturers. For instance, we do parts for energies, for renewable energies, for windmill. We sell parts to agro, and these parts, for instance, the parts in agro that we're selling is for let's say for hog floors in a sense, and these parts are we're able to get them to make them 100% recycled plastic parts using graphene. So technically, the price that we're offering for that product is equal to the price of the product that was offered before, which has no graphene, was made by virgin resin. So we made the product more sustainable. We increase the bottom line for our business, but at the same time, we get the product to the hand of the users, right? So that's pretty much what we have done at the beginning, because the market doesn't exist. So it's not like someone out there waiting and said, "Oh, give me graphene, and it's so good that you gave me graphene." It's not like that. Like, nobody has been using it. It doesn't exist before. So our business model was to prove and validate our business through downstream acquisition and incorporate graphene to the final product, prove that there is no extra cost for the end users to benefit from it, and we increase our bottom lines. And then that give us enough proof that there will be demand for a large volume graphene facility. That's why we built a large facility of graphene, and that's what we're seeing as well, that we're right actually in our analysis.
Okay. For the composites business, can you give me some examples of different parts or auto parts that you guys are selling, and also parts that you have, put in graphene to make it stronger or better?
Yeah. So, for instance, this agricultural part that I mentioned, there are parts that we do with pultrusion. These are the parts that go to the buses, and these are actually like a battery retainer parts. They're for batteries that we incorporated graphene into them and improved the strength. These are the parts that were originally made by metals, so we replaced them with the graphene enhanced pultruded rods. So that's another parts. As well, there are parts for, we showed it in our investor presentation, parts like the hoods for the trucks that are normally, these are glass fiber composites, SMC parts, composite parts. So we incorporated graphene, improved the strength, but at the same time, we were able to reduce the thickness of the part and reduce the weight of the vehicle, rate of the parts for the vehicle. And at the same time, that's how it goes to the end user. So examples of parts, I mean, we sell graphene parts through our Swiss business to a company that does watches, very expensive watches in Switzerland, and these are more of aesthetic parts. It's for having a better surface finish on those parts. There's a lot of different parts.
Okay, interesting. So with your composites business, I'm curious, like how you view your whole business. So you have graphene production, right, with your new plant, and you say it's been up and running for 2 quarters, right? The full production. And then you have your composites kind of business, which does mostly parts, right? To various different, auto industry, or even you say watches, etc. Are those the 2 main parts, or are there other parts of your business also that you're?
No, this is the main 2 parts. We have 2 business units.
Okay.
One is carbon technology, which does graphene, and the other one is composites, which does applications of the graphene technically.
Okay. And
so technically,
Oh, go ahead.
So technically, we produce this graphene as a powder. We have compounding capability, which means we are able to mix graphene with the plastics or thermosets, for instance, or different stuff like that. And then these goes into the composite business unit, which becomes parts. So technically, when you go to the end users, to go to the OEM and show them powder, they heard graphene, but they just can't use it. They don't know how to use it. When you go with the parts that has graphene and already demonstrate the performance, now the selling process is much faster. The sales cycle is much shorter. So our business model is, a typical advancement. Why we did that is because of this. A typical advanced material business, especially when you're the first one doing it, you can't build a plant not knowing where you can sell it, right? And if you don't know where you can sell it, there's no market, right? So there's a chicken and egg, that which one comes first, the customer comes first or the product comes first, right? And in these cases, both are extremely risky. You can't go build a plant and then go turn around and says, who wants to buy this product? And nobody wants to buy the product when there's no supply existing, right? And what we did was we added another leg to our story, which was composites. We went through acquisition, we did downstream acquisitions in order to be able to incorporate our graphene at our pilot lines into the products and give it to the end users and see, okay, do you want to buy it? These are the added values. This is the cost structure. And if they say, yes, we're buying, we pay for you real money for it, then we can actually say, hey, this material actually is real. This business is actually working. And then we can turn around and build a plan and sell that product. Otherwise, without that, you don't have the proof of commercialization. You just can't build a plant.
Interesting. So what, in terms of revenue, would it be like what percent would be coming from composites? I mean, I'm guessing it would be over 90%, right? I mean, because majority of your business is, right, composites to this date.
Yeah, as much you go down the supply chain, have it in mind, the product at the end is 99% plastics and 1% graphene. So, so you get a lot of revenue from plastics, but again, nobody invested in NanoXplore because of the plastics. They invested because of the graphene, right? Now, by the time we are moving towards selling more of intermediate products like master batches of graphene, so mixed graphene, for instance, with nylon, and it's a 30% graphene content in a nylon, and then we sell that product. So again, now you're starting to reduce your growth of the top line, but get a better gross margin out of your graphene, because our graphene in a powder format, we get about 65% gross margin out of that. When we go down in the composites, we get like 25% gross margin out of that. So because we sell a lot of plastics, right? So that's why, we have a drop in our revenue because of the pandemic, because of our auto customers. But at the same time, when the graphene business is growing, there's a bit of offsetting that happens there. But the gross margin is very different. The component of gross margin of the graphene when sold as a powder is really high compared to the composites.
So with NanoXplore, what's your ultimate, like, where are you headed? Are you trying to sell like the graphene powder as your main thing, or are you trying to use that powder to make, let's say, put into nylon, put into different, metals to make it stronger and sell those to the end user? Like, what's the idea?
Let's think about graphene rather than a powder. Let's think about it as a platform technology. Like graphene didn't get the Nobel Prize because it's a cool material. It got it because it brings performances which are unique. Now, we're not China technically. We're not in the business of making millions of tons of graphene and trying to sell those products at a low cost. That's not really the intention of the business. What we're trying to do is we try to provide solutions that comes from our graphene. That's why we're very active in downstream applications, because graphene is an enabler, but you got to go through the process, develop products with the customers in order to benefit from the value out of your product. So how we see it is we are very active in plastics and composites. For instance, we are active in lightweighting of the vehicles, which is of interest to many OEMs. We are active in enabling higher content of recycled plastics into the final product, which I think is a good cause, and people are also really looking for those solutions. And we are getting involved more and more with the energy storage in the battery side. And again, this is what we're doing. We're going one step down the chain, develop products that needs our graphene, and that's how we're playing the platform technology rather than just the powder business.
Got it. Do you think the graphene as just a powder business is vulnerable in the future to, let's say, mass production, let's say in China, et cetera, and that's why you want to add more value going downstream?
Yeah. So any material goes through commoditization process. So I don't want to commoditize graphene. I don't want to be the first one leading the market to commoditize it faster, right? What we want to do is to develop products. Because one thing about graphene is it's not just having a good graphene you can sell. You got to be able to use graphene. Now, the best example is, if you put some sugar in the water and you start to mix it, and the taste of the water start to change, and you transfer the sweetness of the sugar to the water. That's called dispersion. But if you put some sand in the water, as much as you mix this thing, nothing gonna happen, right? So you didn't disperse sand in the water. So graphene is like that. You have graphene it's naturally like a sand. It doesn't disperse in anything. So you have to be able to disperse graphene into different mediums. Mediums are like epoxies, like plastics, like binders for the anodes or whatever. You gotta be able to disperse it in. And when you disperse it in, now you can actually unlock the properties. Okay, so we just don't want to be the powder guy because nobody knows how to mix. You gotta mix it for the customer too, and we do both. And when we do the mixing for the customer needs to be open with you and needs to start share information about the products. That's why we go through long-term validations and product development with all the customers.
If you, let's say, mix something for a customer, let's say you make a better part or something, and they share, here's our part, and then you're able to mix in graphene to make it better, stronger, lighter, etc. Are you like ultimately who owns the part? Is it the company who shares that part with you? Like, are you more like a consultant then, or are you trying to actually create your own parts to kind of develop and sell to other companies?
So IP, if it's a co-development, IP is shared. If the customer is really reluctant to sharing IP, we would have them to pay for the development. At the same time, we would have exclusivity in the supply of the product, okay, in perpetuity. So, and I can tell you, most of the time, they don't recognize that there is value in it. So we own the IP.
Okay, got it. So graphene platform, graphene
As a platform.
as a platform. So are you looking at NanoXplore then as more this graphene tech company that develops lots of different products based off of graphene, because you have not just the ability to make the graphene powder, but you have also the knowledge to mix it and to create stronger, more efficient, lighter, et cetera, products?
Indeed.
I mean, is that kind of your vision or your goal?
Exactly.
Okay.
Yeah, exactly.
And so if that's kind of where you're headed, like, and you noticed, you mentioned several, key areas where you guys are focused. Where do you see the most potential? Like, where do you think that, or are they kind of right now even and nothing has really popped up as the biggest? Like, what's your thoughts right now?
So it depends if it's I mean, we have short-term opportunities, we have mid-term, we have long-term. So short-term opportunities comes from replacement scenarios. So we come in and replace another additive. So we replace almost all the time carbon black. So carbon black, it's a chemical that comes from incomplete combustion of tar. So it's an oil-based product. So all the sustainability angles to the world it's a tailwind for us. It helps us, and people want to replace carbon black. So there is pull in the market when it comes to replacement. These are short-term opportunities. It goes to let's say markets that are not sexy in a sense, but they have very large volume of business. And we are there and we develop product with the customers. So examples of we are doing very good is in geomembranes for agriculture. We're doing very well in the pipe market. We are doing very well in the exterior parts for the vehicles. These are the parts that we do very good, and these are all replacement of carbon black. Now, midterm opportunity for us is when graphene added value is great, but the market is very ready to pick up, and that's for us is energy storage. Energy storage and lithium-ion battery. You know better than me that the market is very growing, and we have a very good added value that comes from graphene. But we don't need to change the world in order to incorporate graphene in those products. Now, these are the midterm opportunity for us, particularly energy storage. And when you go to long-term opportunities, now the opportunities are a lot of different things. For instance, when it comes to electromagnetic shielding, this is a properties of graphene that no material in the world has comparable to graphene. So as much our electronics get stronger and our CPUs are working at higher clocking speeds and frequencies are higher, electronics are more leakier and leakier. Now, think about autonomous vehicles, think about ride sharing applications. So these are exposed to cybersecurity threats, they're exposed to hackings and stuff like that. So one sort of solutions is software type solutions, but also there are hardware solutions here. So graphene is the material that actually can protect the signal from getting out of where it has to go. So these are the type of things that graphene can do. And we're getting traction right now with high-speed trading data centers that we're replacing aluminum chassis with the graphene enhanced plastic. Is very good business for us right now, but we think that this is going to grow really a lot in the future when the market grows when it comes to autonomous. When you talk about IoT, for instance, we have exposure of graphene there. Again, if you Google graphene, you get a lot of those type of applications that are like more of a long-term applications. But our focus today is to replace carbon black, develop products in energy storage, and accelerate our positioning in the market.
Okay, perfect. I want to ask a bit about your background. We want to go back to energy storage. I think batteries
Sure.
is pretty interesting. But I noticed in one of your interviews, you're saying that you have a master's and PhD in, is it nanotech, material science? Is that correct?
Yeah, nanotechnology. Yeah.
Okay. And you studied, I guess, at the University of Barcelona. Can you explain a bit kind of what that kind of experience was? I'm curious before that, like what was your motivation to go into, material science or nanotech? And then what did you learn through your education, right, that maybe led you to this path?
So my bachelor is material engineering. So I'm a like a metallurgist. I'm a more of a metal guy that moved to the dark part of the world, which is chemistry, right? So I did my bachelor 22. I moved to Spain, into Barcelona, and in 3 years and 3 months, I finished my master's and PhD. So it was a very accelerated type process. Um, the thing that I really enjoyed about nanotechnology is this difference that it comes from the real world and the nano world in a sense, and a lot of things changes, and change means opportunity, and from someone that comes from a part of the world that you got to fight for opportunity, this was a great thing for me. So I can really, I had this entrepreneurship background that I have. I was entrepreneur from 14 years old, but then at the same time I was able to study something that was fun, right? So that's pretty much the motivation. And people ask me why Barcelona, why then go to other places. So it's very simple. I like soccer and I like Barcelona. So I kind of like, I mean, I love a bunch of teams, and to me, I was like, I can go anywhere to study because it doesn't matter where you go to study; it's all depending on you. And I went to Barcelona and I studied there. It was a couple of great years of my life being there. Great city to study there. Labs are always empty; nobody actually works, so it's perfect. So you have access to all the labs and everything. But yeah, that was the motivation of studying nanoscience and nanotechnology. It's natural for material scientists to go to nanoscience because this is like the most prestigious part of the world too when it goes to the material science career. But then afterwards, when it's finished, I decided to get a job, and I came to Canada. I got a job, not even a year. I quit, and I said it in other places. I was almost getting fired, so I kind of like took the upper hand, and I just resigned, and I started NanoXplore. But there's nothing complex or, let's say, inspirational in the process. It's just the fact that you start with the small dreams, and those dreams become bigger and bigger each time you achieve the
Mm-hmm.
previous one. So that's
Yeah.
that's pretty much my history.
Yeah. Interesting. When did you go to Canada? Um,
2010,
2010. So it's been about 11 years. And then you started, I guess, NanoXplore in 2011, is it?
end of 2011. Yes.
Okay, 2011. I was listening to one of your interviews where you shared how I think in the beginning you had NanoXplore as a lab for hire.
Yeah.
You were kind of buying lab equipment, broken lab equipment, refurbishing it, and then rather than selling it back, which was your original intention, you decided to keep it and open a lab for hire. So, can you explain or kind of share more details about kind of the genesis of NanoXplore and then how you shifted into becoming a graphene company?
So yeah, so originally, I started buying stuff from eBay, and they were not really functional. So I refurbished them and sold them on eBay. So it was pretty good business. I mean, very good gross margin, I can tell you that. But by the time, you always do a few mistakes in the type of equipments you buy, and they're you fix them, but just can't sell them because nobody wants them. It's too technical, it's too niche, and it's too hard to sell. And by the time when you end up doing a few of those mistakes, you end up with a bunch of assets that they're functional, but they're not generating any profit. And that was when I said, well, till I sell them, I can actually use them as a lab for hire, get contracts, do the testing in house and so on. So I built a lab pretty much, and that lab was uh, keeping the lights on, and it was very modest type of lab. But at the end of the day, we had interest from someone for us to do some graphene work, and we are hungry for work, right? So we accepted the company didn't really make it for us till we finished it, and we ended up, making graphene. And we turned around and says, well, remember you told us something like 6 months ago, and now we have that, but there was no company at that time. So we said, well, right now we have some graphene, which is very interesting, and now why we don't really become a graphene company? And that's when we became a graphene company.
Mm-hmm. Got it. Interesting. So, and when did you decide to kind of, launch your factory, and to really, when did the vision of becoming like a graphene platform company come in mind?
I would say 2015. Yeah, 2015, maybe early 2016. The thing is, well, we learned very soon that if this is supposed to work, you gotta make it cheap. You gotta reduce the cost of production, and that was very obvious because customers we're working with people, and they're like, okay, we're just testing with them, seeing the performance, and the performance is great. But at the end of the day, sometimes we saw it's overkill in terms of people just don't need that much high performance of their stuff, and they're not going to pay a premium to get something that they just don't need. So we turn around and we focus on reducing the cost of production, and of course, you scale the production, you increase the output of your facility. That's you get the cost down. But also there are a lot of scalability challenges that you have to overcome, because producing something small is easy. The moment you want to produce large volume and on a very automated approach, this is difficult. So it took us a couple of years of engineering for this plant, even though construction of the plant took us only 6 months, but the engineering took us more than 2 years. So a lot of thinking went to that, and it's a very cool facility. It's something that I'm very proud of. It's very automated. We only have 3 persons per shift active in there. You can produce with the lights off. It's fully controlled by the servers, and with the this is very smart type of manufacturing.
Mm-hmm. Yeah. I was in one interview you're noting that you could have just one person on the factory floor, maybe a couple people remotely, right? Maybe monitoring, and you can have the whole factory running. What was behind that? Like, how did you come up with that type of idea to run a very automated factory? Because I'm sure there was a lot more more challenges to create something that's very automated. Like, why was that a crucial piece of your factory?
Well, when you look into cost of production, of course, the labor is expensive, especially in North America. So you want to minimize the labor. At the same time, when you have a bunch of people, then you have supervisors of those, and the supervisors needs another supervisor on top of that. So you build a hierarchy of people, and naturally the cost of production goes up and the efficiency of production comes down, and as a result the productivity is low, and again you have extra cost of production. It's very competitive in the world right now for specialty chemicals. Very little company out of Canada, and we needed to compete with big giant carbon black manufacturers in the world. So my idea was, if I beat them at cost, I can definitely beat them at performance. And that's exactly what happened. We got to the cost structure of carbon black, and we reached to the net cost for the end user that are like sometimes cheaper, sometimes at the same cost. And we brought extra performance. It helped us to sell and gain credibility. Otherwise, why to buy from these guys? And who can believe these guys are around another 6 months from now? So there's so much unknowns that you need to incentivize the customers to kickstart the commercial activities.
Mm-hmm. If you wanted to expand, let's say your current factory of 4,000 tons per year capacity, and you wanted to add another 4,000 tons, would you need a new building or a new site, or can you do it at the same place that you have right now?
Well, we are expanding our building right now, so we can actually put another 4,000 tons just in the expansion that we're doing right now. But at the same time, customers are talking more about more of a redundancy, having more than one single location for production in the case that something happened with that location. So we have facilities in North Carolina that we can actually expand the production there. And we have buildings that is capable of doing that.
Okay, got it. So I want to ask a bit more on energy storage. So you noted that midterm that could be a great opportunity. Can you actually before that question, I had another question about your employee count. So I was reading, is it about 400 employees you have, or what's your
Yeah,
your count?
yeah,
Okay,
about 400
400.
employees.
Okay, so out of 400 employees, can you break down like how many are in the composite business versus in the factory versus R&D? Like I don't know how you break it down, but can you kind of give me a categorization of where the 400 people line up?
So we have the corporate side, and then we have two business units. Now, the corporate is probably the order of 30, 40 people. And we have functions like IT and R&D in the corporate. Our R&D team is about 15 people. And all the 15s are PhDs or masters, and they're active in the corporate R&D. So they do R&D of graphene and also R&D of graphene enhanced composite parts. Then we have two business units, and that each one of them is managed by VP Op and VP Sales on each one. And in our composite business unit, we have about close to 300 people, and in our graphene, we have about 50 people. So something then that's becomes 350, 50 to close to 400. There's a little bit of up and down, but I'm just rounding numbers.
So for the 300 in composite and 50 in graphene, is that more for the product sales and for or making the products, or how does that break down?
Well, we have 8 production plants. One is graphene, that making graphene stuff, and the 7 are composites, right? So there's a lot of blue collars that are in those facilities in the composites. Sales team, maybe the two together, maybe about 15 people in both. There are sales people. They're active in sales. So we have application engineers, and then we have territorial reps, and then we have business development people and so on.
Okay, got it. And what do you think your headcount's going to be in 2 years?
I would say organically, like not assuming we do any acquisition, organically, it's not going to change much. Okay. Because the growth of our business comes from graphene, and the graphene growing doesn't require too many people. So it's gonna be maybe tens of people that added to the company, but not more than that.
Mm-hmm. Okay, great. Moving on to energy storage, can you go ahead and explain a bit more on the potential of graphene? I've heard you mention that one of the areas is you could do a graphene net around a silicon anode to enhance its longevity and performance. I mean, can you explain, I guess, give us a higher view on what graphene can do, for energy storage, and then what your guys' strategy is?
So, so graphene can be added to anodes, can be added to cathodes too, right? In the cathodes, for instance, we do a lot of work with the LFP. Graphene adds to the LFP as just improving the conductivity of LFP, resulting into improving the charging speed. In a sense, you actually can charge faster. You can go with the higher C rates without losing the capacity, in a sense. Okay, so that's one side on the cathode side. Now on the anode side, we have this discussion of replacing graphite with silicon. So silicon goes through expansion and contraction when it's charged and discharged. So we have developed let's say a technology that is based on graphene protecting silicon from this expansion. So so the concept is similar to having a kind of a cage or a net around silicon and preventing silicon from the expansion and contraction. Graphene silicon needs to expand to accept lithium, but it should not expand too much that it's kind of like broken to pieces, and it's something called pulverization happen at the silicon. So that's our added value on the anode. There's a small little bit of improving the current collectors in aluminum and copper by coating on the surface of that. It's less of an impact, but still there's something graphene can do. And yeah, so this is a case of it could be the case of normal batteries, let's say lithium ion with the liquid electrolyte, but it's also the same case for the solid states and solid electrolytes.
So for energy storage, like where are you guys at, like in the process? Like, is it more still in the beginning stages, or are you guys piloting, experimenting solutions, or are you guys building some stuff? Like, what's the progress?
So right now we are piloting our batteries. These are graphene batteries. So graphene in anodes and graphene in cathodes. They're not typical graphene batteries that graphene is used as a pure cathode material. They're not that. They're just enhanced lithium-ion batteries. As well, we do a bit earlier stage on the solid state. So we do development already on a binder-free, solvent-free type electrodes. So we're trying to do electrodes that are, you don't have, let's say, water or NMP or those type of solvents in it, and also there's no binder involved in that. So this is important because, well, you know, you want to reduce the footprint of those factories, and solvents and binders are taking so much space in those factories. Mm-hmm. But this is a bit more earlier stage on more of a pilot stage that we are actually making 18650 type cells and this type of typical cells, and we're building this right now in our pilot facility. Okay. It's a small, it's not pilot like a big pilot, it's a small.
Okay, and then what's the point? Are you trying to share these cells, 18650 cells, with companies to? Are you basically trying to validate your claims? I mean, have you validated your claims outside of? Have you made these 18650 cells already? Have in the lab? Yes. Have you validated those claims? And yes. To what extent? Yes. Like, have you done full testing, or is it just kind of in the beginning stages?
So I gotta be cautious of what sort of information I'm disclosing. But yes, the answer is yes. We have done it in the lab. We've worked more than 5 years. We've been very quiet on those things as well because you know why, we've done these type of cells, we've built it, but any technology can work in the lab. It's easy. Building real cells that can actually be produced, not necessarily in terms of performance, but also in terms of manufacturability of those cells, and that's something that we are testing with our pilot line, and by the end of the year we would have results that will define the next steps with those.
Okay, got it. I'm wondering also with the plastics market, can you explain a bit? I've heard a lot about graphene being used as an additive into plastics that improves its recyclability. Are you guys seeing that kind of usage and that demand kind of with customers? And if so, like, where is this headed? Is all plastics going to have some graphene in the future, or what's your thoughts?
Well, we haven't tested everything, right? So we tested a bunch of polymers and plastics that are more used today, like PETs and polyethylenes and like nylons and so on. So, and polypropylene. This type of plastics, the trend is two things. First, to increase the recycled content in the product, go as much as possible, even 100%. Okay. Now, this is achievable and people are doing it already. So it's happening already. But then one thing is, when you get to that level of recycled plastic content, you got to be able to bring the performance. Recycle is in general weaker than the normal virgin plastic. Okay, so there is a performance things right there that needs to be improved. So graphene does that. Second thing is, normal plastic, you reuse them once, and the second time recycling of those, they're crumbling. They're not being able to be used twice. For instance, graphene increases the number of time you can reuse a plastic. Now, I want to make this distinction. That's not recycling; it's reusing, right? So people got to understand that recycling is a bit of different concept than reusing. Reusing, you take it, you just separate and reuse it again. Recycling is you're changing the plastic to something else, in a sense. And also the thing is, there's a bit of there's quite a lot of tailwind for us, because regulations are forcing plastic manufacturers to be responsible for the lifetime of the product. In other words, when they make a shampoo at the end of the life, they have to take that shampoo back to their facility, recycle and reuse it, and make another shampoo out of that, right? So there's customer that there's a pool, they want to do it, and there's of course the marketing side as well, that they want to show that they are sustainable companies. And there are technology limitations that is there. Now, graphene plays in pretty much all of those. Now, the case is different per customer. Some customers are making products that their lifetimes are like 50 years, like pipes. They care less about reusing and circular economy, and they care more about just filling the maximum recycled content that they can do. But some products like shampoos, they care about the upcycle, about the circular economy, and just getting that product back and reusing it again. So they care about more of reusing of those plastics. So yes, graphene has tremendous opportunity there. Is it going to be the only solution? No. Is it going to be the only it's going to go everywhere in all the plastics? I don't know. I don't think so. I mean, but this is a good market for graphene.
Okay. And I'm curious, like, over the next, let's say 18 months or so, as you get your graphene factory, closer to, let's say, full production, and you have new purchase orders and companies coming in, like, what breakdown do you think those categories are going to be in? Like, are they going to be more in the plastic field? Are they going to be more in auto parts? Are they going to be in different areas, or just powder? Like, what's the breakdown kind of?
I think, I mean, I don't have a crystal ball at the same time, but what I'm seeing today is um, uh, applications in consumer packaging, non-food is growing very fast. Industrial is growing very fast. Of course, auto, it's the first market for us, and it's the one that's where we're selling now. So this is also we think is growing. We are under the hood now, and also in interior parts that we're selling, but we think that exterior, it's when it gets to production level now, it's more of a piloting and validation level that gets a good volume for us. Now, which one is going to be the larger one? I think it's important to understand that 4,000 tons, even though it's 45% of global capacity of graphene, but in reality, it's peanuts. It's very small. And we have single customer forecasts that are more than 4,000. And again, for us, it means we can make it. And then we will just follow the customers and put more lines and more production for them close by them. And this is you hit a few of those big customers, and then now you're talking about tens of thousands of tons of graphene. So
got it. And then to clarify, the idea is you prefer to make the end product, right? Not just the powder. So you're trying to mix it,
yeah, we prefer to do no, we prefer to sell powder because and plus intellectual property. That's the best case scenario. So we develop something, but we only sell them powder because I don't need to put capex to build those intermediate products. I don't like to sell those parts anymore, because the parts is too much capex, too little gross profit, too high of a sales number, like too little graphene goes there. So I like to move more of a intermediate products or powder with the IP, not just the pure powder. Powder with the IP is great because powder gives me super high gross margin. It's bread and butter for us. We're doing it now, and the IP is just creme de la creme, right? It's an extra that comes on top.
So ideally, it's actually powder and IP, but then you're also wanting to do products with higher and higher content of graphene, right? So with powder and IP, how does that work? Let's say I'm a company that wants to incorporate graphene into a huge part of my business, my products, and I come to you to put in an order. And is the IP more about how we mix that? You mix that graphene into the product to kind of optimize the product.
Okay. Yeah, exactly.
Got it. And then
so we work with them, develop a product. Now imagine we have co-developed with them, so technically the IP is, let's say, mixed, but then we take some sort of exclusivity of supply, but also we add that value that we created into the selling price of the graphene. So we sell it more than, you know, the $10 per kg, which is like the average selling price that we have. So we sell it at the higher price, and it increased significantly as gross margins.
Got it. What's your kind of proposition when you're, approaching a new company that you think has potential, to add graphene, to their products, to improve them? Is there any kind of like risk-free proposition? You're like, hey, we'll show you something on, how it works, or do you go in it with some type of proposal to come up with a product together, or do you kind of are you waiting for more inbound inquiries? Like, what's your strategy in getting new business?
So almost 100% of our development and sales are people reaching out to us. Like, we don't go out to capture customers. So there are pros in this. But also cons. Like, when we wait for people come to you, they come onto a different type of application from different segments and different markets. Of course, we can't do everything, right? So we're very selective now, and focus on the application that we know, and we know that there's added value. Earlier days, when you do not really expect clearly what the product can do. As much more you try with different customers, there are failures, of course, in the process. There are successes in the process. You know where the product works best and where it doesn't work, right? So then you focus on those ones that are working well, and you use the knowledge you acquired from the previous guy for the next guy too. And then by the time the sales cycle is dropping from 5 or 6 years, it's dropping to like 2 years now, and we're hoping to get it down to under 1 year, which is our key, because now these long development cycles are very difficult to get return for, right? Because you're spending a lot of R&D dollars there.
Can you explain this long sales cycle? Like, what does it look like? Why is it, let's say 2 years or something? Like, what are the main steps in that sales cycle?
Typical, for instance, with Martin Rea, we announced a product, and that was more than 2 years of development with the customer. And at the mark of 3 years, we started selling products. So what it is? So the concept it's jackets for the fuel lines and brake lines in the cars, fuel lines for internal combustion, and brake lines for for electric vehicles, and these type of products, this type of fuel lines and brake lines are exposed to a lot of abrasion, and it's under the car, right? It's a hostile environment, so there's a lot of abrasion, erosions, and all sorts of corrosion type thing. So these are normally covered with the jackets to protect those lines. So now, to get the job done, historically it was multiple of layers of jackets. Now we took all those layers out. We only kept one incorporated graphene there, and we actually increased the lifetime hundreds of cycles, hundreds of times. And the product, it was just too good, and then the customer decided to reduce the thickness of the part because it was an overkill, and reduce the weight, reduce the cost. When you go through these steps, there are first step is like R&D validation. You actually deal with the R&D department of the customer. Next step is product validation. The third step is certifications and product validation by the OEMs and the field test, or let's say if there are specific regulatory things involved you have to pass, and those type of things, right? So the sales cycle, not just get some graphene and dump it there and it works. It's a lot of development involved in this. That's why there's a lot of know-how and IP involved in these things.
Interesting. So when do you think we'll start seeing an uptake on announcements from your company in terms of new kind of companies having purchase orders? Or when do these sales cycles, I guess, for you come to fruition? Is it just kind of continuously over the next few years as you guys close more deals and do more R&D and prove out your applications?
Well, the thing is this. We asked the question of why we should do an announcement. because all the time when we get a customer and we get purchase orders and stuff, I know all the shareholders like to see a bump in the stock, but we don't like the short-term shareholders. We like long-term shareholders, and long-term shareholders, they see the impact in the long term. And in the last 12 months, our stock like double, tripled almost, and we still haven't announced anything. And so the question I always ask is, yes, I mean, we can announce today, we can do like 10 press releases of the customers that we're selling the product to, but why we should do that? like like our stock is doing good. We needed to raise money. Like we raised money in March 19 of last year, right in the pandemic. Our 5 major shareholders, they didn't even let me to go out, and they just bought the offering. We did financing recently. It was oversubscribed by a large margin. So we're doing good. I mean, we don't see why we should start announcing anything we do.
Got it. I hear you. So I'm curious. Yeah, I'm curious in terms of the automobile applications you talked about. Is there ways where, I mean, I'm wondering if it's more complex than just, obviously it's more complex than just adding graphene to different parts, but it seems theoretically that, if you add graphene to different parts in the right way, you can make them lighter and stronger, right? I mean, are there limitations to this? Can you just do this for the entire vehicle?
Yes, you can do it for entire vehicle. Now, okay, not entire vehicle. There's parts that is still like metal parts, especially like chassis. Like strength is too high, and graphene addition to the plastic, because there's still the matrix is plastic, which is way weaker than metal. Even though you improve the performance, you don't get to the steel, right? We are able to meet aluminum properties even sometimes, and the customer is like, I don't want any composite on my mission sensitive parts because I want metals. Metals are strong. So there's a perception and there's a performance. So not necessarily everywhere you can add graphene, but a big chunk of parts in the cars could be graphene and will be composites going forward. You'll see we've developed foam technologies with our graphene, which are bringing a lot of cool properties to the vehicles in terms of vibration proof, in terms of heat isolation, in terms of soundproofing, in terms of electromagnetic shielding, and like half of it is air. So they're highly light, they're very light, and they're very strong at the same time. So these are the type of things that comes out of the products that are based on graphene. We do graphene, but also we develop these things that comes out of the graphene, right? And then these parts are important. Like I know that everybody loves to have a much better batteries. We do too. But you actually can get better performance by making cars lighter, and they drive more. So the range doesn't necessarily comes from a better battery. It comes from better battery, but also at the lower weight of the vehicles. And we tackle both. We reduce the weight, bring strength through our composite activities, but also through our batteries, we work on the energy density in terms of cycle life and range and so on like that.
Mm-hmm. I'm wondering, I mean, with graphene, are you typically adding it to more plastics to make, let's say, composites, or can you add them to metals as well to make them stronger? Let's say like steel, etc.
Well, we have not added to the metals at all. We added to the plastics and composites. We have done a bit of work with ceramics, but metals, I think it's doable, but there's a lot of changes in terms of manufacturing process. You just can't cast graphene because it just decomposes. You need to do powder metallurgy, and you need to do sintering type process and so on when you deal with metals. And so that's a different way of incorporating graphene.
Okay, interesting. Going forward, like with NanoXplore, what do you think are your main challenges, that you are having to deal with and overcome, that would profoundly shape your trajectory and where you're headed as a company? Like, what are kind of the top, couple things?
So the way I see the market is we're going through some growth in the next couple of years for graphene uptake, but there is the hockey stick and the point that it starts to jump. Now, um, as a company that's leading this market, we really impact the point that critical mass point that this inflection happened. Our challenge is to bring it as closer as possible, right? So we're more advanced than our competitors, but if the time to market and the inflection point is too late, so our competitors reach to us while we're still stagnating to get to that level, right? So we need to speed up the process, and how we speed up that thing is by validating products as fast as possible. So our carbon black replacement becomes a very important part of our business that brings revenue and profit very quickly. We don't need to sell a lot of product to become cash flow positive. Like we are, at our type of fundamentals, like uh, half the plant makes us cash flow positive, selling half of our existing plant. So it's not like we need a lot of revenue in order to be cash flow positive. But I like to become cash flow positive as fast as possible and capture the market as fast as possible, because if we can actually get it done faster than the normal process, we actually can replicate and build more plants, and just we can actually dominate the market. And I think we have this position right now. And things like graphene is not like things that comes and goes. It's not like a gizmo that people use it and then afterwards shift to something else. It takes long time to get the product into the market, which means the customer loyalty gonna be high. It's very difficult for them to switch your product to somebody else's product, right? So it gives the first mover advantage is important. It gives us a lot of competitive edge to make this process faster. So I would say speed of commercialization is the first thing that it's not concern, is more of a challenge that we're facing now.
Mm-hmm. Okay. With your back to your batteries, I mean, this is fascinating to me. I know you can't share a ton of it because obviously you're still piloting your 18650 cells, but how much are you relying at all in terms of partnerships with other battery researchers or other companies or places to help you build these 18650 cells, or are you just doing it just completely in-house? Like, how are you getting that battery expertise to make some pilot cells?
So we're doing the production of those batteries in-house right now. Okay, so we're making those, but we spend I would say 4 years with a partner. We went through development already with them, and they helped us a lot in perfecting our technology in a sense. But when it comes for manufacturing, we have to do it ourselves. Pretty much, we have to prove that what we have done in the lab, which people like, can be also achieved in a bit more larger volume and more of a industrial settings. So yeah.
Okay. Got it. The 4 years of development, was that what type of development was that? Was it actually making some lithium ion cells with graphene?
Yeah. So you start with coin cell, right? With this little cells that goes to your watch and stuff like that,
Mm-hmm.
and you validate. Silicon concept is not new; it's been around for a long time, and protecting silicon has been a challenge, and that's what we've been able to do with the graphene, and also some sort of a polymer that helps to keep things together, and then afterwards you got to transfer this to the 18650 or different dimensions of the cell. Of course, the 18650 is the more widespread one, and so we took that dimensions, and we built a bunch of 18650, but like we built like 15 of those, which are like done in the lab, and it's not automated in terms of manufacturing. It's not like industrial. Now we're moving toward industrial manufacturing of those, and we even may continue and go with another larger demonstration facility for those type of cell if it's successful. But again, that's information that yet to come.
Okay, got it. So when you did the coin kind of development, were you able to validate kind of your hypothesis that graphene added
Yes.
was improving. Was it improving? I mean, was it improving the charge rate on the cathode side as well as kind of the longevity, I guess, on the anode side, on both sides?
Yeah. Yeah. So the thing is, a typical LFP can get to 160 watt hour per kg. So our target is to get to 200. We're not able yet. We're at 180. And I think 180 LFP is something that hasn't been reported by anyone in the world now. So we're meeting, I mean, the best one is like 160, 165. We are already at 180, but we got to prove that in the industrial scale. But the target for us is to further improve the LFP and get to 200. To me, LFP is a great chemistry. It's better than NMC and NCA for many applications because it's a bit safer. The thermal runaway at the much higher temperature, so it's a safer type battery. It also doesn't have cobalt, which kind of helps. You don't want to deal with cobalt these days. And so LFP, I think it's going to gain a lot of market share, but inherently it's a low performing and low capacity type cathode. So improving the capacity, improving the charging speed helps. But then to improve those type of LFP batteries, you just don't need to necessarily make a better cathode. You can actually improve the anode at the same time. And if you may have a better anode, you can have a thinner coating when it comes to anode. And if when you're rolling, it can actually roll a little bit longer. And that extra length of roll in a single cell gets you to a much better performance. So these are different ways of innovation through manufacturing that comes. But yeah, we also in the anode side just stabilize silicon. I mean, a stabilization of silicon, it's not a 0 or 1, it's always a ratio. So as much more of a silicon you have in your formulation, as lower cycle life you end up having, and as higher let's say capacity you will end up having in your anode. Okay. So the challenge is to increase the silicon content, not lose the cycle life, and like get to 1,000 cycle by 80% of capacity retention, which is the key in many of those applications. So we are able to increase silicon to quite good numbers.
I mean, it seems like the LFP market is growing substantially, especially with electric vehicles. And it seems like, because, also there's no cobalt, but also doesn't have as much nickel as other types of batteries. It seems like there's a lot more, resources to scale LFP. If you can develop or actually have technology that improves, the watt per kilogram or kilowatt hour of battery, watt per kilogram battery, I'm wondering, why don't you just go all in on LFP? I mean, this is like probably one of the biggest markets out there. Why mess around with, parts and composites and plastics or whatever? Why not go just put it all in with LFP or batteries? Or is there some reasons why you want to spread out your bets? Are there some potential hiccups or challenges or doubts that you have in terms of LFP and how revolutionary some of the improvements can be?
Well, people like batteries. I mean, I understand. I understand my shareholders love when it comes to the battery, and they just don't even want to hear from plastics or any other things like that. But at the end of the day, the dollars that come in, it's regardless of where the dollar is coming in. It's still dollars, right? And one thing that we have to avoid is right now, of course, the applications of energy storage is very hot, and you're being super high valued for anything you do in the energy storage. But at the end of the day, the winner is the company that creates cash flow. Cash flow is the thing that sustain a company, regardless of how much time, which part of the history we are in. It's gonna end one day, and if you don't have a cash flow to sustain yourself, you're gonna pay for it big time. So what we do is we just want to make sure that we capture profit from different part of our business. At the same time, look at the batteries. The amount of technology is going into the battery, and a lot. You have solid states. You have solid state, all solid state. You have lithium sulfur. You have lithium air. You have aluminum air. You have zinc air. You have all sort of different chemistries for the battery, right? Yes, today is lithium ion, and people are selling it, and and we're doing good there. Is it going to be 10 years from now? It's going to be lithium ion? Is it going to be lithium like a solid state? Is it going to change to lithium sulfur? Like there is a lot of unknowns technologically when it comes to the batteries. And pretty much the question comes back to Mr. Musk. If tomorrow he decides to move to do lithium sulfur, is like total world gonna change and do lithium sulfur. And when you're in the middle of something, and we do work, right? We do work to get, he talks, but we actually get to that point and try to deliver those things that he comes to the battery day and said we actually work toward that. But when he moves to the next step, and if we're just in the middle of something, we lost everything that we have done. So we got to be very careful. It's a very fast-pacing market. We don't want to pretend that we are Panasonic or Samsung or anything like that. We are who we are pretty much, and we got to be nimble and have the success paths all open. So in the case that we fail in one, we have of course something else that we're generating money. And I hope we actually deliver all of them, because then the profit would be absolutely great for the company. We are in a position that if graphene markets become what it's supposed to be, we will have a great business. But if the graphene market is not graphene, the one that media is talking about, our business really need cash flow to sustain. So we need to have all these different opportunities available for us.
Got it. In terms of graphene becoming, a huge market, what are the big challenges? Is it just, you talked about the chicken egg problem where people need to see the usage. They need to see the products. They don't want to per se, invest a ton of money and resources in something that isn't proven. Do you think it's like, how inevitable do you think the graphene market is to become huge? Is it just, in your mind, just a matter of timing, whether it's 10 years or 5 years, or are there other factors involved, you think?
It's the timing. The chicken and egg problem is solved today because there is a supplier today that can actually make graphene in large volume at the cost that makes sense. Okay, so this is done. We've done it. Okay, but then there's the adaptation process comes, and how long this adaptation takes for it to get to the that explosion point. It's difficult to impact and difficult to accelerate in a sense. Now, to me, it happens. I've seen different type of chemicals and materials that they have got the Nobel Prize and they have been very interesting and lots of good performance, but they fail to get to the point that that there is production at low cost. And the most famous one is carbon nanotube. Carbon nanotube went through the process, but it was very difficult for it to be produced in large volume at cost. It happened way later, and the moment it happened, the market started to grow. Carbon fiber is the same. If you look at the variation of the carbon fiber total production and the total market size by the time, you see that the moment the production actually happened in large volume, in less than 3 years, the market spiked and it actually grew very quickly. And now just imagine in terms of dollar per kg, we're today cheaper than carbon fiber in terms of selling price. Carbon fiber goes the lowest grade at $14 per kg. We're doing a 10 already. So we got to that point that we bring the cost and this performance versus cost ratio. We meet that, right? So technically we should be very close to that point, but we will see. Right, we will see if that point actually happens the way we think. So far, it has been very good. The reaction that we are getting from the customers are absolutely phenomenal. Like people they didn't believe that this is actually doable. Other competitors of us thought that we're lying. Actually, it's not real. And we brought competitors inside our plant and showed them our cost structure. Still, they can't get it. Like it's not possible. No, it's possible. Like we have done it, and it's happening. Though you need this click to happen, and this start to grow. And when that happens, if it's close, we have a very good business. And again, I'm trying not to promote things. I'm a bit more sometimes too much passionate about my business, but in reality, it's something that's happening right now, and we're seeing all the good signs for it.
Got it. I mean, to paraphrase, would you say that, you see, just a matter of time before there is kind of this explosion, because you have the cost structure now is there for graphene.
Yeah.
It's just a matter of the time. It could be later or shorter. And in the meantime, you want to make sure as a CEO, to protect your business where you can survive with cash flow in case that explosion point is a bit later than maybe some people expect. Is
For
that
sure.
pretty much the point?
For sure.
Okay.
For sure. Yeah.
Got it. For those interested in wanting to learn more about graphene and the business, what would you suggest them to do? Are there any, good books or any, good resources out there that, really explain what's happening with graphene? How can we get a better understanding?
Well, there are a lot of materials on YouTube, right? So at the moment you YouTube graphene, there's a ton of different videos that comes and you can learn. And there are different market reports out there that are credible. There's one. It's a UK firm called ID Tech X, and they have been early. They're doing very good reports about the graphene, and they have been very early in the graphene story. From early days they have been around, so they're very knowledgeable about the space. And of course, well, I wrote a book, but it's too technical, so I don't recommend it for anyone to read it other than the scientist. But technically, there's a lot of materials out there when it comes to graphene. Not all of them are credible. There's still many reports out there saying that, well, the problem of graphene is the cost of production. Gosh, what happens if somebody does that? And that was 2 quarters ago, and it's already done. So the reports out there, but honestly, all of them are credible.
Got it. Okay, cool. Wanted to thank you for the deep dive into
Sure.
graphene and to NanoXplore. I think definitely have a lot of exciting things on your plate with so many different industries, different potential going forward. I wish you the best with NanoXplore in the future. We'd love to connect with you also, maybe in 6 to 12 months to hear on progress on what you guys are doing.
Yeah.
I think it's a fascinating market. I mean, this is, newer material, I guess, and the applications and the future is yet to be decided, with where it's headed. It seems like you guys definitely are in the mix with determining that future, on where it heads. So definitely thank you for your time.
Thank you very much, and thanks for having me here. The next 12 months going to be very interesting for NanoXplore, and I invite everybody to have a close eye on our progress. And in 12 months we sit and talk, and probably some of those questions that you keep asking, and I'm constantly saying, well, we'll talk about this. Those names and those questions will be available, and we can talk about those.
All right, thank you, Soroush, and we'll talk to you later.
Perfect. Thank you. Bye.
Bye.